No previous noise both preserves continuity over corners and allows high-quality anti-aliasing. The most popular solid noise primitive is Perlin noise. As we can see, it preserves continuity across corners. It can be filtered with frequency clamping, but this results in loss of detail. Wavelet noise attempts to improve filtering quality, but it uses projection, breaking continuities across corners. Gabor noise also uses projection, and thus breaks continuity across corners as well. However, Gabor noise uses analytical filtering, and thus achieves high-quality results. Our random phase solid Gabor noise both preserves continuity across corners and allows high-quality filtering. In this paper, we show that continuity across corners requires slicing, used by Perlin and our noise. Wavelet and Gabor noise use projection, which breaks continuity across corners. Directly slicing Gabor noise results in a phase shift. To model this phase shift, we introduce the phase-augmented Gabor kernel, which allows us to define random phase Gabor noise, which can now be analytically filtered. As a result, we can treat complex scenes such as this partial model of the Parthenon. Continuity is correctly preserved across corners, and when looking at the marble wall, analytical filtering gives high-quality results. In addition, our noise inherits the properties of Gabor noise and allows us to model anisotropic materials such as the wood of this chessboard, or the patterns of these chess pieces and statues.